Hello and welcome to the today's video lecture in which I am going to explain the hydrothermal synthesis of nanoparticle preparation. So actually it is one of the lecture in a series of lectures where I have explained how you can synthesize nanoparticle through various methods such as the co-precipitation, the sol gel synthesis, and the today's video lecture, that is the hydrothermal synthesis, and other methods of the nanoparticle synthesis. Okay, so all of these lectures are going to be placed in a playlist that you can browse on my channel. So moving on towards the today's video lecture, that is the hydrothermal synthesis. Well, the hydrothermal synthesis, as the name says, hydro means the solvent would that be of water, and thermal means that you have to provide the heat. Okay, so for the hydrothermal synthesis, what you have to do, you have to just take different salt, then you have to mix them in a water, and then you have to stir it, then you have to set the pH, then you have to transfer it to the autoclave, and then you can wash it, and then finally calcine it. So for explaining this hydrothermal synthesis, I am going to take an example of lanthanum cerium ferrite. So for the formation of lanthanum cerium ferrite, what I am going to do, I am going to take all of these three salt in the desired ratios. I am going to take the salt for lanthanum, I am going to take the salt for iron, I am going to take the salt for cerium in the specified ratio, in the specific ratio that I want, and then I have to do, what I have to do is I have to mix all of these three salt in a beaker with the water. So I'm going to do, what I'm going to do is I'm going to mix all of these three salt in water, and then I have to stir it for 30 minutes. As you know that dissolving all of these three salt will make this solution acidic, so I have to set the pH for this solution. For this I have to add 0.2 molar NaOH sodium hydroxide. You can use 1 molar, you can use 2 molar, you can use 3 molar depending on your choice. So you can use the sodium hydroxide for setting the pH to basic. So what you have to do, you have to set the pH to basic round about to 10-11, and then what you have to do, you have to stir it for further 30 minutes, and after doing that you have to transfer it to the autoclave. In this example I have used 140°C temperature and the reaction time for 18 hours. Normally for the formation of metal oxides, what do? We perform the 180°C, we perform this hydrothermal reaction at 180°C and 24 hours. In this example I have taken 140°C for 18 hours because this can be formed at a lower temperature and at 18 hours. So after placing the autoclave in an oven with a temperature of 140°C and 18 hours, you have to just get this autoclave out. You have to get this material out of this autoclave and into the centrifuge, into the Falcon tubes, and these Falcon tubes that you can place in the centrifuge machine and wash it 3 times with the DI water and wash it 3 times with the absolute ethanol, and then finally you can dry it in an oven. And after that, if you want to perform the calcination, you can perform the calcination of your products, and then finally you have to characterize your sample using the SEM or other methods. So this was just an example for lanthanum cerium ferrite. So for generally the hydrothermal method works on applying the wet chemical technique. So what do we have is, we have the wet chemical techniques, mean the solvent would be that of a liquid. Okay, so the process is carried out in a sealed container. So as you can see that this process is carried out in this sealed container, and the temperature is usually from 100 to 250°C depending upon the type of the nanoparticles that you are going to form. So highly crystalline ferrite nanoparticles, that is the alpha Fe2O3, the gamma Fe2O3 and so on, they can be precisely developed by this hydrothermal technique. So moreover, hydrothermal synthesis methodology maintains a good control on porosity and composition. So using this hydrothermal method, we can control the porosity of our substance, we can control the composition of the substance by using the different ratios of the salt. Okay, so just changing the ratios of this salt, we can control the relative composition, and also by changing each of this salt we can change the composition of our final product. So the materials that have very high vapor pressure equal to, that is very near to their melting point, they can form nanoparticle only by the hydrothermal method. So if we change the water, if we change the solvent from water to that of ethanol or to some ethylene glycol or to some any other solvent, then we can say that this method is a solvothermal method. Okay, so all of the reaction procedure will be same. What you have done, you have just changed the DI water into some other solvent, and that solvent can be ethanol, ethylene glycol or some other solvent in which your salts are miscible. Okay, so in that case the process will be called as the solvothermal method. So the solvothermal method is similar to hydrothermal method. The wetting liquid is different. You can use an organic solvent instead of water, and the synthesis route is quite advantageous. So this synthesis route is actually quite advantageous if you want to synthesize the iron oxide nanoparticle. So moving on towards the advantages and disadvantages of this hydrothermal method. So first of all, the advantages. Actually, there are most materials can be made soluble in a proper solvent by heating and pressuring the system close to its critical point. Well, there are some materials that cannot be formed by the solid state, the solid state reactions. In the solid state reaction, what do we have is we just mix two different solids. Okay, we just mix two different solids and then we heat it, and then the resulting product is formed. But many of the materials can't be formed by solid state reactions, so for that we need a solvent, and by adding these chemicals in the solvent and by placing them in the autoclave and then performing the reaction at the required temperature and time, you can form the nanoparticle of those substances that cannot be formed by the solid state reaction. So in this we have the significant improvement in the chemical reactivity of the reactants, and furthermore again materials which may not be obtained via solid state reaction may be prepared through hydrothermal and solvothermal synthesis, and then products of intermediate state and the metastable state as well as the specific phase which may not be easily produced by some other method, these products can be easily produced by the hydrothermal synthesis method. So one of the most important advantage of the hydrothermal method is that we have easy and precise control of the size. Okay, so the nanoparticles that are being formed by the hydrothermal synthesis, in these nanoparticles we can easily control the size, we can easily control the shape distribution, and we can easily control the crystallinity of the final product by adjusting the parameters. Okay, we can we can control the size, we can control the shape distribution, we can control the crystallinity by changing the temperature, by changing the reaction time, by changing the solvent type, by changing the surfactant type, and by changing the precursor type. Okay, by changing any of these conditions you can control the size, the shape, and the crystallinity of the final product. Well, all of these advantages belong to the hydrothermal method, but there are also some disadvantages that you need to understand. So first of all, there is the need for these expensive autoclaves, and there is this safety issues during the reaction process, and this you cannot observe this reaction because this reaction is taking place in a autoclave, and that autoclave is placed in an oven, and just you cannot monitor it. You can just see the temperature, or you can just see the time remaining, but you cannot monitor what's happening inside that autoclave. So that is just one of the disadvantages. And there is the inability to monitor crystal growth. Similarly, if you cannot see what's happening inside the autoclave, you cannot see how the crystals are being formed. And furthermore, we have the method can only be performed under supercritical solvent conditions. So for the hydrothermal synthesis, you have to achieve the supercritical conditions for the solvent in order to form the nanoparticle with perfect size, with perfect porosity, and with perfect shape distribution. So the final disadvantage is the longer time period. Actually, for this hydrothermal process, much longer time period is required for the formation of nanoparticles. Let's just say for the formation of mixed metal oxide, you have to perform the hydrothermal synthesis for more than 24 for about 24 hours, for about 18 hours, and that is hell of a time. That is much longer time. So that is one of the disadvantages that you can see in the hydrothermal synthesis. So this was all about the hydrothermal synthesis. If you have any question, you can ask me in the comments and I will reply. Don't forget to like my channel. Oh, sorry. Don't forget to like my video, subscribe my channel, and follow me on Instagram too. Thank you and Allah Hafiz.